So, good day sa lahat. Uh, so today, let's tackle about our next topic, which is moment distribution method. So, this time siguro class is, we go directly, yung approach natin is ibahin natin. So, we will not tackle anymore about the history, kung paano i-derive to moment distribution method. So, I know you are already reading references or the PDF book that I have given you, okay? O kung nanonood ka nito at hindi ka naman estudyante ko, so maybe nagbabasa ka ng libro, no? Medyo mahaba at saka hindi ganun kadali yung derivation ng mga formulas. So, sa topic natin ngayon, so iibahin natin ang approach natin. So, we go directly to the application, okay? So, moment distribution method, so just like slope deflection method and other force method, so this is actually a method in solving indeterminate beams, okay? So, first, maybe let us draw an indeterminate beam. Okay? So, start muna tayo sa indeterminate beam. Okay, so maybe let us say it has two spans. Okay? Na may fixed on both sides and then pinned at the middle. Oh, let us say na meron tayong assume nyo na lang na moment okay, so assume nyo na lang na na straight na meron, let us say we have uniformly distributed load na 8 kilonewton meter, and then we have 6 meter length, and here let us say 5 meters siya. Okay, so this is 6 meters, 5 meters, and lagyan natin ng point load na sabihin natin 20 kilonewton. Then from the left, 3 meters siya, and from the right, 2 meters siya. Okay? So, ganito. Okay, so paano ba isolve tong beam na to using moment distribution method? Okay? So, first of all, so ilagay ko muna yung mga dapat nating dadaan. So, first of all, we must compute the FEMs for the fixed end moments. Okay? So, pasensya na, medyo maliit yung board natin. May batang makulit pa sa background, okay? Compute the FEMs or the fixed end moments. Then, the second one is pareho lang sa slope deflection method. And then, okay, so is compute the stiffnesses, okay? Or relative stiffnesses. Okay? Pag sinabi kasi nating okay? Pag sinabi kasi nating stiffness, it will refer to as K. Okay? K. Okay? So, i-discuss natin mamaya ano yung K. Then, the next is, okay, we compute the distribution factors, or here is TF. Okay, so tandaan nyo na lang class. Okay, so we will discuss further as ano tong stiffness or relative stiffness, ano tong distribution factor. So ganyan yung dapat nating mga tandaan. And then compute, after ma-compute natin ang distribution moment, then compute the distribution, okay, of moments. Okay. So yan. So yan yung mga steps natin. Okay? So first, compute natin si fixed end moments. Then next is i-compute natin si stiffnesses. The third one is we compute the distribution factor. And then lastly, we compute the distribution of moments. Okay? So medyo actually simplified lang to. Yan yung pagka-explain ko, pero mas maintindihan natin ano ba tong kung if mag-solve na if i-try nating i-solve ito, okay? Para maintindihan nyo. So, maybe you can copy this one, okay? So, i-record nyo. Or else, kung tinatamad kayo, pwede nyong i-post. And then, basahin nyo ng mabuti, okay? Para matandaan nyo. Okay? So, okay. So, first, mag-construct tayo ng table, okay? So, ito, pag sinabi kasi nating distribution of moments, hindi to madaling i-explain, no, in simple terms. So, maybe buburahin ko muna to, okay? So, you visit this na lang, okay? Pwede nyong i-backtrack itong video to kung hindi nyo matandaan itong mga steps, okay? 4 easy steps lang yan. So, let us start computing this one, okay? So, first and foremost, computin muna natin si FEM, okay? Ito yung first step natin na sinabi ko. Sinabi nating FEM, ito yun. Or fixed end moments. Okay? So, we know, okay? Sorry, hindi ko nalagyan ng ayan. So, let us say na ABC itong beam natin. Okay? So, we have MAB. Okay? FEM AB is equivalent to negative WL squared over 12. Okay? I hope natandaan nyo yung formula ng fixed end moments. So, marami yun eh. Negative 8 times 6 squared over 12. Okay? Okay, so we compute. Ito, magiging negative 24 kilonewton meter. Okay? Yan yung sa left side dito. Okay, fixed end moments niya. Then, fixed end moments at BA is equivalent to positive WL squared over 12. Okay? So, magiging positive 8 siya times 6 squared over 12. Okay? So, 36 times 8 is divide 12 is equal to positive 24 kilonewton meter. Okay? So, and then, next is, we compute naman yung fixed end moment PC. Okay? Okay. So, si fixed end moments BC natin is P, okay? PAB squared over L squared. Ang A natin dito is si 3 meters, okay? At yung B natin is si 2 meters, okay? So, negative. So, negative 20. A is 3, then B is 2 squared over the total length, which is 5 squared, okay? So, 12 to 40. 25 is equivalent siya sa kay 9.6 kilonewton meter. Then, so therefore, FEM CB is equivalent to positive PA squared B over L squared. Okay, so positive 20 times 3 squared times 2 over 5 squared. Okay? So, tama ba yung sagot natin? Okay, 4, 12. 3 squared, 9, 18, 360 divided 25. So, this is positive 14.4 kilonewton meter. Okay? Okay? So, pakicheck nyo na lang. So, tandaan nyo, ito yung unang bahagi. Okay? So, maybe, okay, tandaan natin, negative 24, 24, negative 9.6, and 14.4. So, yun yung first step natin. Na-compute na natin si fixed end moments. So, the next step is, computein naman natin si, okay, stiffnesses. Okay? Computein natin yung mga stiffness or relative stiffness ng beam. Okay? So, erase ko muna to ha. Magsimula tayo ulit kasi maliit yung board natin. So, the next step natin is compute natin sa stiffnesses. Okay? Okay. Okay. So, please remember this formula, okay? So, we have K. So, we have a general formula which is K is equal to 4EI over L, okay? So, tandaan nyo to. So, where E here is the elastic modulus. I is the moment of inertia. Of the cross-section area. Of the beam. Okay? So, ito yung uniform niya na K or stiffness. Okay? So, yung L natin, alam natin, length yan. Length of beam. Ay, length of member. Kasi pwede rin nakatayo. Okay? Yan. So, under normal conditions, you can assume that K is equal to 4EI over L. But somehow, meron ding technique doon sa books natin na pwede nating i-modify yung si K. Pwede nating at certain conditions, magiging 3EI over L siya, maging 2EI over L siya, or maging 6EI over L siya. In order na ma-shortcut natin yung computations. But somehow, para mas madali, doon tayo sa hindi masyado nakakalito. So, we'll take K as equal to 4EI over L regardless of the form of your beam. Okay? So, actually, itong stiffness class, okay? It doesn't matter kasi itong constant na 4. Okay? Okay? So, by the way, maiintindihan nyo habang nagsosolve tayo, ano bang gamit itong si stiffness. So for this, memorize nyo muna to. K is equal to 4EI over L. Okay? So, and then, the next thing, okay, para dito sa beam na to, we can compute the K. Okay? So we have, okay, sorry. So, maghanap ako ng bagong Okay? So, we have K of AB. Okay? Hit this. So, merong iba't ibang stiffness yung members natin. Okay? Dito, meron tayong dalawang members ng beam. Si AB at saka si BC. So, si KAB natin dito is 4. Okay? Let us say, hindi ko nalagyan. Wala kasi sinabi. So, pag ganito lang, let us consider AI as constant. Okay? We can consider AI as constant kung hindi siya given. But somehow, sa mga questions sa libro, actually, sinasabi doon, consider AI as constant. But somehow, madalas may value din si E at may value din si I. So, don't worry kasi I will give examples na given si E at I at meron din questions, example na problems na constant, dineglect si EI or kino-consider na constant. Okay? So, let's proceed lang for this example muna. So, for EI over the length, 6. So, therefore, 2/3 over EI si KAB. And then, si KBC is equivalent to 4 EI over 5. So, therefore, okay na yan. So, let us not round off it, no? Kasi, hindi maganda if i-round off natin to kaagad, class. So, magiging erroneous yung solusyon natin. Okay? Hindi masisiro yung shear and moment diagram natin kapag nag-round off tayo ng nag-round off. So, let us take it as fractions. 2/3 EI and 4 EI over 5. So, next, na-compute na natin ang fixed end moments, na-compute na natin ang stiffnesses. So, I hope naalala nyo yung mga sinulat natin sa board kanina. Yung MAB, MBA. So, MBC and MCB. Okay? So, yan. So, the next thing we should do, okay, the third step is to compute the distribution factors. Okay? So, here, okay, erase ko muna. So, tandaan nyo na lang. Pwede nyo balikan yung mga nasolve natin kanina kung nalimutan nyo. So, we have, okay, distribution factors. So, this is the third step. Okay? Or DF. So, tandaan natin na meron sariling, may distribution, okay, sa bawat member. Okay? So, let us say that the distribution factor, okay, distribution factor of this, okay, distribution factor of the outer part, okay, the outer support at A is equivalent to 0. Bakit? Pag fixed. Okay. So, pag compute ng distribution factor class, may sariling distribution factor itong outermost supports. Okay? So, itong outermost supports, okay, lagi niyong tatandaan, may sarili yung distribution factor. Kapag fixed, okay, kapag fixed yung distribution, ang yung outside supports, yung pinakagilid na supports, yung ibig kong sabihin, pag fixed siya, automatically yung distribution factor niya ay 0. Okay? So, what if pinned? So, if pinned to, okay, so kung if pinned to, o di kaya ruler, okay, at kung if pinned o ruler yung outside, magiging 1 siya. Okay? So, it should be 1. So, DF is 1 if pinned. Okay? So, I hope naintindihan nyo. So, kapag ang DF mo is 0 kapag fixed yung supports mo, outside support. ay kana okay, in exterior support. And then 1 if pin or roller support, yung exterior support, okay? Then exterior support, okay? So, sa bawat supports, either dito sa side A o dito sa C, kasi nasa hulihan sila, okay, nasa exterior side sila ng beam, support ng beam. So, ang distribution factor nila, it's either 0 or 1. 0 kapag fixed, and then 1 kapag pinned or ruler. And then, yan, para madali. So, sa pag-compute naman doon sa, okay? Sa pag-compute naman doon sa nasa gitna, okay? Kapag nasa interior supports, so paano? Okay? So, sa bawat member, whether, for example, AB, on BA, iba yung distribution factor niya. So, let us say DF, AB, is equivalent yan kay KAB over KAB, okay, KAB alone, okay? Kasi isa lang yung, pag sinabi nating AB, okay, from this point to that point, so isa lang yung, ano niya, no? Isa lang. So, therefore, it is equivalent to KAB over, over KAB. Okay, isa lang. Okay. So, magiging, ang distribution factor niya is, okay, sorry. So, dahil, okay, dito na side, kasi yung AB natin, nagsimula siya sa fixed side. So, therefore, ito yung nasa exterior supports yung unahan niya, which is A. So, dapat 0 siya kasi fixed. Okay? Fixed exterior support. Okay? Yan. So, si DFBA naman. So, paano natin computein? So, si DFBA is equivalent to KAB. Okay? BA kasi. BA. So, tandaan niyo yung nasa unahan. So, ibig sabihin, nasa sa gitna siya ni AB at saka ni BC. So DFBA is equal to KAB plus KAB over KAC. Okay? So, we all know na yung KAB natin is 4EI over 6. And then, yung KAB natin is 4EI over 6 plus 4EI over 5. Okay? So, paano? Okay? So, we can cancel out EI. Okay? Para hindi magulo kasi may EI in both sides. So, 4 over 6 or 2/3 over 4 over 6 plus 4 over 5. Okay? So maybe let us produce this as fraction. Okay? So, kuha muna ako ng calculator. Nasa na yan? So, 4 divided 6. No. 4 divided 6 divided by 4 over 6 plus 4 over 5. Okay? So, therefore, it is 5 over 11. Okay? Is equal to 5 over 11 or 0.455. Okay? I-3 decimal place lang natin. So, and then again, si DF, okay? Tapos na si BC. So, DFBC naman tayo. Si DFBC is equivalent to, nasa gitna siya ulit, BC. Okay? From B to C. So, Therefore, it will be K, B, C, okay? Yung mismong length, kasi AB, B, yung sa DFBA is B to A. So, ibig sabihin, yung length ng AB ay ano natin, i-consider dito. Kay BC naman kasi from B to C. So, KBC over KAB, doon sa left niya, and then, plus, okay, KBC. Oh, okay. BC to BC. Okay? So, therefore, we have, so, si KABC natin is, ano yan? Si KBC natin is 4 over 5 EI over 4 over 6 EI plus 4 over 5 EI. Okay? Compute natin. Okay. So, is equivalent to 6 over 11 or 0.545. Okay? So, yun yung distribution factor natin. 5 over 11 o 6 over 11. Okay? We'll take it as fraction na lang para hindi malaki yung error natin. So, we have dito ko na lang isulat. So, si DF, CB, kasi yung unahan niya is nasa exterior side, and then it is fixed, DFCB, so therefore, it is 0. Okay? So, actually, yung meron ding value ng K, C, A, and C, kaya lang infinity. Okay? Infinity yung ano nila, yung K nila. So, therefore, magiging 0 din to. Okay? So, okay? Kasi magiging something like merong value ng K dito sa ibabaw, then merong isa dito sa ibaba na infinity. So, any number divided by infinity is practically 0. Okay? Kaya ganyan. Okay? So, tandaan nyo, we have DFAB 0, DFBA 5 over 11, DFBC is 6 over 11, and DFCB is equal to 0. So, yan. Tapos na natin yung ikatlong step. Okay? So, erase muna natin to. Okay? Pwede nyong stop dito kapag hindi nyo masyadong naintindihan. Okay? So the next thing is we compute the distribution. But somehow we cannot compute it is actually a vector. Kailangan nating mag-construct ng isang diagram, okay? So here, ang una nating ilalagay is joint. Okay, joint. So meron tayong tatlong joints. We have A, then B, and then C. Okay? Lagyan natin, okay, C. And then, lagay natin, meron tayong mga member. Okay? So, yung member natin is si, AB. Under kay A, meron tayong member na si AB. Okay, AB lang. Kasi nasa labas siya. Then, kay B, meron tayong BA, member BA, at BC. Under kay C, meron tayong member na CB. Okay? Yan. Ano pa ba? So, the next thing is we put the distribution factor. Okay? Yan. Okay. So, natatandaan nyo pa ba natatandaan nyo pa ba yung distribution factor natin? So, yung distribution factor natin is okay, so the distribution factors natin is dito is 0. ito is 5/11. Okay? Fraction lang tayo. 6/11. And then this is 0. Okay? Sa libro niyo is naka-decimal place. Pero sa atin, mas mabuti siguro if i-fraction natin para mas accurate. Pero at our final answer, i-round up lang natin into 3 decimal place. Okay? Para magkaintindihan tayo. So then, the next thing is we would write the fixed end moments. Okay. So this is meron ta iterative kasi itong moment distribution method. So meron tayong sabihin nating cycle 1. And then after the cycle 1, we have dito natin ilagay yung mga distribution. Yung ibang libro, ang tawag dito sa distribution is balancing moments. Kaya instead of this, yung nakalagay, yung nilalagay nila. Lalo na if yung nagtuturo ang nagtuturo is veterano na guro ng structural analysis. Dating mga libro is balanced to, okay? So this is the first cycle, okay? So tandaan natin ano ba yung okay? So yung yung fixed end moments natin is negative 24 dito, 24 dito, okay? Negative 9.6 and 14.4, okay? Yan. Okay? Tama ba? I-check ko muna ha. 30. Yan, okay. Tama. So then, okay, so, yan. So, tanong natin, paano itong distribution? Paano computein ito si distribution? So, meron tayong formula, okay? Meron tayong formula para dyan. So, yung si distribution natin, si this, okay, ilagay ko dito, the distribution moment is equivalent to the df times, okay, times the sum, times the sum of moments at joint. Okay? Times negative 1. Okay? Yan. Ganyan yung formula niya. Okay? So, this is how, okay? So, maybe hindi nyo to makita sa libro kasi yung formula, ginanito ko na lang para mas maintindihan nyo. Okay? So, here, the distribution factor, okay? The distribution factor natin is equivalent to, okay? Kasi dito na joint, at joint A, okay? Joint A class, ito lang yung member niya, si member AB. So, therefore, ang isa-sum up natin is negative 24 lang, negative 24. So, ang M joint natin is automatically negative 24. So, i-multiply mo by DF, which is 0, and times negative 1, so we have 0. Okay. So, here, kay B, di ba, ang summation of M joint natin is equivalent to, i-add mo tong dalawa, lahat ng fixed end moments mo at this under B, under joint B. So, therefore, 24 plus negative 9.6 equals 14.4. Okay? So, ito yung M joint natin. So, pero iba yung pag-compute natin sa distribution ni BA at kay BC. Kay BA, 14.4 times distribution factor, which is 5/11. Okay? 5/11 times negative 1. So, 14.4 times 5/11 times negative 1. So, therefore, meron kang value na negative 6.545. Okay? Yan. And then, Ito naman, para naman kay BC. So, iba lang yung distribution factor niya, pero i-multiply mo pa rin. Okay, so M joint mo is si 14 point pa rin. 14.4 pala. 14.4 times the DF, which is 6/11, times negative 1. Okay, so therefore we have negative 7.855. Okay. So, dito kay DFCB, erase na natin to kasi tapos na natin yung gitnang joint. Isa lang yung member niya, which is CB. So, si 14.4 mo, i-times yung M joint mo. So, i-multiply mo siya kay DF, which is 0, kasi fixed nga eh. 0 times negative 1, so this is 0. Okay. So, that is cycle 1. Hindi pa tayo tapos. Okay? Meron pa. So, proceed tayo. Meron na tayong cycle 2. Okay? And then, so in this iterative method na moment distribution method, pwede kahit ilang cycles yung gawin mo. Okay? But sa minimum of 2 cycles. Yung first cycle is FEM at merong isang distribution. Then, meron pang isa. We have another term called carryover. CO or CO. Carryover moment. Okay? Yan. Pag sinabi natin carryover moment, ang value niyan is, okay? So, let us say CO carryover of AB is equivalent to, okay, this distribution of BA over 2. Okay? So, ganyan yung general formula niya. So, yung kabaliktaran, pag sinabi natin carryover moment ni AB, equivalent siya sa distribution ni BA divide 2. Kung kay BA naman, yung distribution as carryover ni BA is equivalent to distribution ni AB over 2. So, yung i-divide mo lang ng 2, yung corresponding distribution moment niya na nung kabaliktaran niya ng pangalan. Okay? Si AB, computein mo yung distribution factor ni BA. Okay? Divide 2. At yung CO ni BA kay AB naman. Okay? Okay, gets nyo? Nag-criss-cross lang sila. Kay BC, for example, kay BC naman, COBC, yung yung distribution na i-divide mo ng 2 is kay CB. At kung si CB naman yung hinahanap natin, si BC kay yung distribution naman ni BC. So, ibig sabihin yung kabaliktaran niya ng pangalan, yung i-divide mo ng 2 yung distribution para yun, at therefore, yun na yung carryover moment mo, okay? Lakihan natin kasi medyo maliit. Okay? So, sana nag-gets nyo? Okay. Yan. So, yung cycle 2 natin is C, carryover. So, dito, since COAB is equal to this distribution at AB over 2 ay BA over 2. So, therefore, yung kalahati niya. So, i-divide mo to ng 2. Okay? So, negative 6.545 divide 2. Okay? Magiging negative 3.273 siya. Okay, yan. So, ito, dito, okay? Parang na ganito ba? O, ayan. Ayan. So, therefore, carryover moment ni BA is equivalent to the distribution at AB. Previous distribution at AB over 2. No, nag-criss-cross lang sila. So, therefore, 0 divided to 0. Dito naman, carryover moment ni BC is equivalent to distribution at CB. Okay? So, distribution at CB is 0. Diyan, oh. So, therefore, 0. Okay? So, okay, meron yata ako ditong pula na marker para makita nyo ng nasa na yun. Yan. Yan, oh. Nag-criss-cross lang sila. Kumbaga is okay, sorry. So, itim lang talaga yung gumagana. Sorry, class. Okay? Yan. Nag-criss-cross lang sila. At ito, i-divide. And then, yung carry-over moment ni CB naman is equivalent to distribution at BC. I-divide sa 2. Okay? Nagbabaliktad-baliktad lang sila. So, 7, negative 7.855 divide 2. Okay? So, we have negative 3.973. Okay? Na-round off ko na sa 2 decimal. Ay, 3 decimal place. So, then, yan. Pagkatapos niyan is, balik tayo kay distribution. So, ganon din yung formula natin. Okay? So, si this natin dito is equivalent to, okay, the distribution factor times the summation of moment at joint times negative 1. Okay? So, distribution factor natin dito is 0. I-multiply mo kay negative 3.273 kasi yung M joint natin kang A. So, M joint AB at okay, at AB is 0 ay negative 3.273. Okay? Pero i-multiply mo man sa kay 0. Okay? 0 to si DF mo times negative 1, so 0 to. Okay? So, what about kay B. Okay? So, kay B naman, i-add mo lang to si carry over moment. Okay? Ito yung tinitingnan natin, no? I-carry over. Okay? So, 0 plus 0 equals 0. Okay? So, anything you multiply by 0 is 0. So, 0, supposed to be, multiply natin siya kay 5 over 11 times negative 1, so 0 siya. Okay? So, 0 times 6 over 11 times negative 1, 0 siya. Okay. And then again, okay, negative 3.973. Okay? Kasi ito lang yung member niya. So, kay joint C, okay, ang distribution factor, ang summation of moment at joint niya here is negative 3.973. Okay? So, i-multiply mo siya kay DF, which is 0. So, magiging 0 siya. Times negative 1, 0. Okay? So, dahil 0, 0 na lahat, i-add natin lahat yan. Okay? So, pwede natin masolve yung mga moments. So, ang gagawin natin, i-add natin tong mula kay FEM hanggang dito. Okay? So, i-sum up mo siya. Okay? Dito natin ilagay. So, you sum up everything. So, we have negative 24. Okay? So, this is negative 27.273. Okay, negative 2 ha. So, i-add mo to. So, 24 minus 6.545. So, this is, okay, so this is 17.455. Here, negative 9.6 minus 7.855. So, we have negative 17.455. And here, 14.4 minus 3.973 is 10.427. Okay? Yan. So, yan yung mga moments natin. This is equivalent to moments at AB, equivalence to moments at BA, equivalence moment at BC, and this is the moment at CB. Okay? So, yan yung mga moments natin. Okay? So, maybe, okay? So, yan yung moment distribution method. Okay. So, what if, magtanong kayo sa akin, class, what if hindi zero to? Hindi nag-zero. May pagkakataon na hindi nag-zero. So, kapag hindi nag-zero, magkakaroon ka pa ng third cycle or cycle 3. At uulitin mo tong CO at dist. Okay? Yung CO at distribution. Okay? So, for example, may cycle 3 ka, dyan, add ka lang ng CO at saka ng dist. Okay? So, maybe, we'll have another example. Okay? Let us say, a second example on the next video. Okay?